Okay, so this is where we left off yesterday. We were kind of working through this Gaussian process to get a simpler system of equations to help us solve for our x, our y, and our z in our system. And we were doing that by using those elementary row operations. So remember, that was being able to interchange rows, multiplying a whole row by a factor, multiplying by a row, and then adding it to another row in order to make something become a 1 or a 0. And if you remember when we talked about this yesterday, our goal was to get the diagonal to be 1s, which we did end up achieving. And then we wanted all of these to be 0s, which we also see happening in this as well. Okay, so this is where we left off yesterday. We're going to go to another example, and we're going to do the same thing, okay, but we're going to start it from scratch. And I'm actually going to move over here so I can point while I talk, because it seemed to work better yesterday afternoon if I was kind of pointing at what we're doing. Can you guys still see okay? Okay, I'm going to go ahead and start by writing out my matrix with all my coefficients and my constant. So my coefficients, remember, would be those numbers in front of your x, your y, and your z, and then your constant would be the number that's after the equal sign. So I'm going to write this first one as 2, 1, 2, 18, and then we're going to keep doing that. So the next one would be 1, negative 1, 2, 9, 1, 2, negative 1, 6. Everyone clear on where I'm getting those numbers from? Yes. Okay, so remember, my goal here is I want to get this diagonal 2, negative 1 to just become 1s. Now, 2 out of the 3 are already 1s, so this probably won't take me a whole lot of work to make these switch because I just got to switch these signs. But I do need to make this 2 become a 1 somehow. Okay, now we can do that a lot of different ways. I try to think about, is there a way that I could maybe multiply another row by a number and then add it to this 2 to cause it to become a 1? That's usually where my mind is at when I'm trying to do this. Okay, so another thing we could do, if you're not opposed to decimals, is we can divide this whole row by a 2. Does anyone care if we do that? No. The only decimal you're going to have is right here. So if you want to avoid a decimal, then you might have to think about a different way to do that. But if we're all okay with that middle term being a decimal, I think that's going to be our easiest way to start this. So here's how I like to kind of write it. I'll draw like an arrow after the row, especially if I'm starting these from scratch, like I don't have anything helping me out. I like to draw an arrow next to the row that I'm going to kind of manipulate here. And on my arrow, I like to write what I'm doing. So I'm going to take row 1 and I'm going to divide it by 2. You can also think of that as multiplication. Like you could think you're multiplying by a half. So if I take row 1 and I divide by 2, it's now going to say 1.5, 1, and 9. The other 2 rows stay as is. Okay. Now remember, I like 1s here. If we want to, we can go ahead and switch these signs right away. We could just multiply both of those rows by negative 1s. That would go ahead and switch these to 1s for me. And then I could just focus on how do I get these to become 0s. Okay. The other thing is you don't have to do that right away. You could then think about how do I make this a 0 instead of making those become positives. It might be easiest though if we do switch the signs, because then I'm thinking these would be opposite signs, and so those would be easily cancelable. And same here and here. So maybe let's try to do that. I'm going to write that again with my arrows. I'm actually going to do 2 of them this time. I'm going to multiply both of these. I'm going to take negative 1 times row 2, and I'm going to take negative 1 times row 3. You could split those up into individual steps. You can combine them together like that. As long as they're not going to impact each other, you can kind of condense some of that work to one step. So I'm going to squeeze this in here at the end of my page. So the top row stays the same. And then this middle and third row are going to switch their signs. So now it's going to say -1, 1, -2, -9. And then the bottom row, -1, -2, +1, -6. Okay, I've got all ones diagonally. That was the whole reason why I did that. Now let's start thinking about how we're going to make the -1, -1, and the -2. We need those to become zeros. So let's focus on the second row first. So I'm just going to copy down my first row of numbers. So 1, 0.5, 1, and 9. But let's think about what we can do to the second row. How could I make this term here, become a 0? Can we add it with a row? What row do you want to add it to? The first one. So we're just going to take row 1 plus row 2. Okay, and again, we're back over here when we do that. So we're taking 1 plus -1, 0.5 plus 1, 1 plus -2, and 9 plus -9. That is going to make this no longer a 1, but that's okay. We can go back a little bit later and we can fix that. So if I add these together, this would be 0, 1.5, -1, and 0. Okay, and my bottom row is staying the way it is. I didn't do anything to this one. All right, so I've got a 0 here now. How could I make this one a 0? Could we add again? What row should we add? So again, row 1 and 2 are staying as they are. Okay, so now if we add row 1 plus row 3, that'd be adding these two, so that's a 0. 0.5 plus -2 would be -1.5. And then 1 plus 1 would be a 2 here. 9 plus -6 would be a 3. Okay, so when I did that, some of you are probably thinking, well, that just messed up our row of 1, like our diagonal of 1s. You're right, it did. But that's going to happen sometimes where you start to manipulate to get those zeros. It's going to start to impact those 1s that we had. But once you get enough zeros here, you're going to start to be able to do simple operations to single rows to get it back to a 1. Okay, so I'm not too concerned about that right now. I do want this to be a 0. How can I make that become a 0? Yeah, let's add row 2 and 3 again. Okay, so if we add row 2 and row 3, that'd be 0 plus 0, which is 0. 1.5 plus a negative, 1.5 is 0. -1 plus 2 would be 1. And 9 plus 3 would be 12. Okay? Last thing I need to do is I got to get that. I have zeros everywhere that I need them. I need 1s in my diagonal. So I've got a 1.5 here. This is really the only thing I need to focus on, getting it back to just a 1. Again, if you're okay with working with decimals, we could divide by 1.5 on that row. It's not going to impact a lot of them because some of them are already zeros. So it's not really going to change anything there. So let's go ahead and I'm going to draw this out again. I'm not changing anything to my first row. I'm going to take row 2 and I'm going to divide by 1.5. So this would be 0, 1. What's negative 1 divided by 1.5? I don't know what that is. I'll need a calculator for that. Negative point. Is it repeating?
Yeah.
So that, I'll just write it as a fraction. That would be negative 2/3 as a fraction. And then 0 divided by 1.5 would be 0. Yeah.
Shouldn't there be a 3 with a 12 is?
Yeah. Well, how did I get 12? It should be a 3, but I'm trying to figure out where my mistake was. Oh, I put 9 plus 3, not 0 plus 3. So this just needs to become a 3. That's what I did. Okay, thank you for catching that. All right, so if we look now, I've got 1s in my diagonal. I've got 0s here, which means I can stop at this point and I can start using my substitution to work my way back. Remember, when you're looking at these numbers, this is your x, this is your y, and this is your z. Okay? This last row, I don't have an x anymore. I don't have a y anymore. I just have z. We're saying z equals what? 3. So when I think about these as equations, this top one would be, think about what we did on our bell ringer today. This top row would be 1x plus 0.5y plus 1z equals 9. I'm still going to need that to help me write out my other equations to solve for my other letters. So I'm going to write x plus 0.5y plus z equals 9. And then I have, what would this second row say? Good. And then the last one we said z equaled 3. You have one of your answers already. You have z equals 3. So we just start to slowly work our way backwards. We can take this 3 and we can plug it in right here and help us solve for y. Okay, so that would look like this. Y minus 2/3 times 3 equals 0. What's 2/3 times 3? 2. The 3's cancel. So you have y minus 2 equals 0. So what does y come out to be? 2. So there's another answer. So z is 3, y is 2. We can go back to that top equation there to help me solve for the x. So we don't know x, but we know we can put 0.5 times a 2 now because we know y is 2. We can put in a 3 for the z, and we're setting that equal to 9. This would become x plus 1 plus 3 equals 9. What's x going to come out to be? 5. So my final answer, just like last chapter, we were writing ordered triples. We're doing that here too. 5, 2, 3. Okay. That's using that Gaussian substitution process. So you get your 1s as your diagonal, you get your 0s here, you start to work your way backwards, okay? However, okay, Gauss was this guy who created the Gaussian process, okay? And there was another guy who came in, his last name was Jordan, and he said, well, hey, how about instead of stopping when you get those 0s, so instead of stopping here, what if we make these numbers 0s too? So we're adding in this other step to continue those row operations to say, if we get these all to be zeros, guys, you don't have to do any of this work. It's going to be in your matrix, x equals this, y equals x, z equals x. So whatever those numbers might be, it's just continuing those row operations. So this is using elimination instead. And so that's what we're going to see. Now, before, this is from a previous problem in our notes. Okay, so we did this before. This was like 2 problems ago. So not the one that we just did, but 2 problems ago in your notes. This is the system that we stopped with when we were finished. What we did in that last problem is we started to substitute back in. We said z was 2, we plugged it back in here, we plugged it back in here to solve for x and y. What we're going to do is pick up where we left off, and we're going to zero out this area so that we can see that we're going to get the same x, y, and z that we got before. Okay, before 2 problems ago when we did that, that was the first problem I kind of reviewed when we started today. The answer was 7, 2, 2. So when we get to the end here, we should have a 7, a 2, and a 2 here. Now, I already have that on the bottom. The bottom row is good. So I just need to work with these top 2 really to get those to be zeros. They're kind of giving me guidance here. They want me to start out by taking row 2, column 3. So row 2, column 3 would be this negative 2 right here. They want to make that a 0. Okay, so let's think about how we could do that. Since the bottom row has a 1, if I take 2 times this bottom row and I add it here, they would be opposites and they would cancel. So I'm going to write that next to it on this row here. I'm taking 2 times row 3 and I'm going to add it to row 2. Okay, so I'm not changing row 1 or 3. I'm going to rewrite those out. Okay, let's think about this mentally here. We're taking 2 times this row and then adding it to here. So what's 2 times 0? 0 plus 0 is 0. So that term is unaffected. Same thing's going to happen here. We're taking 2 times this 0, that's another 0, plus 1. So that middle term is still a 1. So once you start to get a lot of zeros, these ones are not going to be impacted by our math. Now, if we do this next one, 2 times 1 is 2, plus that negative 2 zeros it out. That's the whole reason why we're doing this. And then 2 times 2, 4, plus negative 2, 2. Okay, I've got my z solved for here, and I've got my y solved for here. Z is 2, y is 2. Remember, I said my answer was 7, 2, 2. So I just need to get a 7 up here now, but I got to get these to be zeros. So let's think about how we can do that. They want us to start with row 1, column 2. So they want us to focus on the negative 4 first. So let's figure out a way we can get this negative 4 to become a 0. So let's think about that for a second. What do you want to do?
4 times the second row.
And then add it to the first row, right? So 4 times row 2, add it to row 1. If we do that, what's the row going to say?
0. Oh, wait, top one?
So you're taking 4 times this row, and then you're adding it here. So 4 times 0 plus 1. 4 times 1 plus negative 4.
0.
4 times 0 plus 3.
3.
And then 4 times 2 plus 5.
14.
13. The other 2 rows stay as they were. Okay, last thing we need to do is we got to get this 3 to become a 0. How do you guys want to do that?
Divide by 2. Oh, 18 and divide by 2.
That would make it a 1. I want a 0.
Take the bottom row times 3. Add it to, or negative 3 and add it to the top one.
Okay, so negative 3 times row 3 plus row 1. Yes. There's going to be a lot of that. When you're trying to get 1s or 0s, you're going to be multiplying by an opposite number so that you can add Okay, so let's think about, again, we're back here now. So negative 3 times 0 is 0, plus 1 is 1. This is just going to be a 0, okay, because it's 3 times 0 plus 0. Negative 3 times 1 is negative 3, plus the 3 is 0. That's what we wanted. Negative 3 times 2. Negative 6 plus 13. 7. Isn't that what we wanted? Okay, when you're done, there's no substituting. The answers are in the matrix. X is 7, Y is 2, Z is 2. So,
like that bad, but like actually, what would you use this for?
Seriously,
like other stuff I get, like geometry and like other stuff I get.
There would probably be times like if you were trying to, like in like chemistry, again, like those mixture problems we talked about, where you're trying to mix this element with this element and you wanted to know how much of each you would do. You could use matrices for that. It's not necessarily faster than what we did in the last chapter. Okay, let's finish the problem that we ended with when we did that one by hand. So let me write that matrix down. So we had 1, 0.5, 1, and 9. 0, 1, negative 2/3, 0, and then we had 0, 0, 1, 3. That was the problem that we did 2 problems ago now. So the one right before this one, so I'm just going to scroll up so you can see where I'm getting that from. This one here, but we stopped it here. Okay, now we're going to just take this same matrix, that's what I just copied down, and we're going to continue with the elimination. So I want to get more zeros here. I've already got my 1s. I want to make these become 0s. Let's start with this. I don't know. It doesn't really matter where you guys start. You want to start with the 0.5, or would you rather make this a?
Let's start with the 0.5.
Okay. Let's make this a 0. So how can we do that? I want a 0. Take what times?
The 0.5, the top row times -2, and then add it to the second row. Would that make it 0?
Yes. I would maybe try to do something here, only because I don't hate what you're saying, Tanner, but if you do that, it's going to change this from a 1, because this is now going to become like a -2 plus 0 is -2. So it might be easier if we do that thinking here. How could we make this 1 and this 0.5 be opposite signs? We can multiply by -1/2, right, to make it -0.5, and then add it up here. That won't impact my 1 here because you'll be taking 0 times something plus this, and that won't impact the sign. So I'm going to take what you said there, -1/2, -0.5, times row 2, and we're going to add it to row 1. So you're going to take -0.5 times 0, which is 0, and you're going to add 1. So that just stays 1. -1/2 times 1 would be -1/2. Plus a 1/2 becomes that 0 that we wanted. All right, now we might need a calculator for this one. What is -1/2 times -2/3? So do that multiplication first, and then add 1. 4.3 repeating. Can you make that a fraction for me? Just hit that double arrow button. 14/3? 13/3. Positive or negative? Okay. The only reason why I like the fraction is because then I'm going to think later, how can I get rid of that fraction? So I want to see the denominator to help me with that. Okay, this then last one would be negative 0.5 times 0, which is 0, plus 9 is 9. Okay, everything else stays the same. Okay, so we have some fractions there. We need to make them become zeros. Maybe let's zero out the 13/3 first. Let's just take this bottom row times the opposite of that. Since this is a 1 here, I'm going to take this 1 times a negative 13/3 because it won't impact these at all. And this will zero out, and then we can figure out what happens down here. So I'm going to write down what I just said. Let me get my matrix drawn. For this top row, I'm going to take negative 13/3 times row 3, and I'm going to add it to row 1. Like I say, it really won't impact much on the first two terms because you're taking this number times zeros, and then you're adding it to the 1 and the 0. So those are still going to be 1 and 0. Here's where the math comes in. So negative 13/3 times 1 plus the 13/3 zeros it out. You're probably going to want to think about this next one. Negative 13/3 times 3 would be what? Negative 13, and then you add it to 9. What's negative 13 plus 9? Negative 4? Is that what you said?
Yeah.
0, 1, negative 2/3. Okay. I don't know if I like that.
That's kind of wacky.
Because we got a 5. So did we do something? Did we miss something? Can I see your calculator real quick? That's okay. Did you get 5 on the top?
Yeah.
Okay. Let's make sure that these fractions are right. Can I see your calculator once more, Adam?
Like this is like
I got it.
do whatever the hell you see if it works out. Ours are sharp.
Yep. Plus 1. 13/3. Okay, I agree with that. 0 plus 0 plus 9. Okay, let's keep going with this. I'm gonna have to come back and look at that top one because it should be a 5, so I need to figure out what happened there. But let's continue on with this second. Let's make this 2/3, negative 2/3 become a 0. How can we do that? Times the bottom row by 2/3.
That's what I got rid of first.
That's what you got rid of first?
Yeah, and I did that.
Did you get 5 then? Okay. Yeah, I'm trying. It should be a 5, but I just can't see what happened up here. Oh, row. Yeah, no, I got to figure that out. Okay, so if we do this, 2/3 times row 3, so 2/3 times 0 plus 0 is 0. Another one here is 0 plus 1 is 1. 2/3 times 1 is 2/3, plus negative 2/3 is 0. 2/3 times 3 would be 2, plus 0 is 2, which is good. And then 0, 0, 1, 3. All right, so what is the issue with the top row? Why are we not getting 5? I must be missing something. Because we got 5, 2, 3 when we did this 2 problems ago. So I'm trying to figure out what happened in either this first step or this step to get me a negative 4, because it should be a 5.
Is negative 0.5 times negative 2/3 4/3? And not 13/3?
But then you have to add row 1 to it. So it'd be 4/3 plus 1. I'm going to keep looking at this. It should be a 5, guys. This should be a 5. But I got to figure out what happened here. I'm going to get you guys your homework, though, so we're not just all sitting and
Is that the
staring.
equation?
Yes.
It's gonna be 4/3, not
4/3. So how do we get 13/3? Yeah, because negative. So this should be 4/3, not 13/3.
Yeah.
I don't know how we got 13. Which just means I changed this number to a 4/3. Negative 4/3. Times row 3 plus row 1 should get me 5. The other number should not be impacted. This should just change to a 5. Because negative 4/3 times 1 plus that top should end up being a 5. If you take, yeah, it'd be negative 4 plus 9, which is 5. So I don't know how we got 13. So that's all right. So your answer here should be 5, 2, 3. All right.